well, wait a minute, what about security? We haven't really talked about that very much. So why might you need security? Well, if you're building a FHIR server, you probably want to make sure that it can't get hacked. If you're building a FHIR app, that probably pertains to a lot more people. There are vulnerabilities there too. Data has to flow between things. Really, any kind of application you're building on the internet can get hacked. It's been happening. You're not safe if you're using cloud infrastructure. You're deferring a lot of the security pieces over to Amazon and Google and Microsoft or whoever else your cloud platform is. But there's still things you need to do. Really, if you're connected to the internet in any kind of way, you can be hacked. And in fact, even if you're not connected to the internet, there are things to do with air gapping and putting a USB key into drives. So really, security should pertain to everybody. Here's some statistics from a telecom company in the US called Verizon. They put together a breach report every year. 53,000 hacking incidents were reported. Of those, about 2,000 were actual data breaches. That means data was lost in some way or compromised. Most of the hacks actually use known vulnerabilities that have often been around for years and years and years, and people actually know how to resolve them or patch them and don't do it. Of those, healthcare was actually the single largest victim as an industry. Almost a quarter of all hacks reported in 2017 were actually in the healthcare industry. Actually, an interesting stat on here that I don't have a lot of, I'm not discussing a lot in the presentation, but more than half were actually insider threat. So primarily like nurses looking up like celebrities who are in the hospital or things like that, which all get reported in this statistic. That's sort of a different problem from what I'm going to talk about today, but that's an interesting thing to keep in mind. So why do attackers target health systems? Well, here's a general hacker business plan. Thanks, South Park. So let's look at the profit motive. This is really, 3/4 of all hacks are really about profit for some reason. Well, if you have people's data, you can do credit card transactions on their behalf. You can take out mortgages. You can claim benefits from the government or from insurance companies. And get paid to do this. And if you don't want to do those things yourself, you can sell the data to somebody else who will. And in addition, ransomware is actually becoming an increasingly big problem. In the last year or so, it's begun to be offered as a service. So you don't have to have a lot of hacking knowledge now. You can go download some ransomware code and set up a site for collecting Bitcoin payments. And then ransomware attacks are becoming much more rampant. And they're not necessarily as dangerous as they were last year, but it's an increasing threat that you should be thinking about. And that's really, as long as you have a breach in your system, ransomware can get in. So there are a couple other reasons why people attack healthcare sites as well, or really any site. So we've heard about espionage from various foreign actors, but you can also graffiti a site. If you have a political statement that you want to put out there, that might be the motive in itself. There are also a couple of big denial of service attacks that you may have heard about in the last couple of years where a large hacking collective has decided we don't like what this website's doing and they try to take it down. And in addition, in the healthcare industry in particular, you can actually have targeted attacks. And these are usually much more about targeting an individual profile. And that could be somebody else's profile, like a celebrity we talked about with insider threat. It could be you're trying to do revenge on somebody or blackmail. But you also could actually modify your own health record. You could create a pain medication order and then go and get it filled at your local pharmacy and then be taking opioids you weren't supposed to be taking. Or you could be an athlete and you could take a drug test and go and alter those results if you were able to hack into whatever system it was. And then ultimately, the thing we don't like to talk about but can in fact happen is attacking medical devices themselves in hospitals. Those tend not to be very secured, or at least not as secure as they should be. There are opportunities in there. If you wanted to, if you were really determined to do this, you could actually go and alter somebody's, IV thing, or, administer a dose of something automatically that they're not supposed to get, or, fake their EKG data and then they die. So that is actually a big deal.
Has that ever actually been documented?
An actual case of it happening, no. Although this year there was a great presentation on something called the doctors were able to modify clinical tests en route to the EHR and to other systems that could have resulted in the death of various patients. Insulin spikes that initially presented as like dehydration.
Right.
They've even made a male pregnant according to his
Right.
his medical record. But
Probably didn't kill him.
Right. Well, so thanks. So Dan's one of my coworkers. He's the actual hacker. I just play one on TV or on stage, apparently. So yes, that was not using FHIR. That was actually using, I think, V3. But it is a thing that you want to be aware of. Could happen. We know now nation states are actually becoming more interested in exotic assassinations. That is a thing to look for. So we all talk about, in the healthcare industry and in FHIR in particular, we talk about personal health information. That's what a health record is, right? But that's not the only thing that's actually valuable to hackers. There's personal identifying information, credit card numbers, financial information. That is also worth something. To sell it on the open black market, it's not as valuable as health records, but that's still a target you want to protect. And just basic business operations information. If you have an employee list, that's something that a hacker could, someone trying to do damage to your organization could potentially use that for nefarious purposes. So I'll talk now about some common types of attacks. This is by no means a complete list. There are a lot of new things coming up all the time. These ones are sort of fairly standard or have been used a lot, or and there are some things in here specific to the FHIR protocol as well. It's also worth pointing out that attacks usually will actually involve more than one technique. So a hacker will gain access to a system in some way, and then they'll pivot and use a different technique to gain access to a different piece, and then they'll sort of work their way through the system. So really, it all starts with bots. Bots is really the sort of the modus operandi of getting into a system. Hackers are inherently lazy. They don't actually know what all the vulnerabilities are themselves necessarily. They just run a fleet of bots who go and find the vulnerabilities for them. And they say, hey, I found this thing. Sometimes it's actually just randomly targeted blanket on the internet. They don't even know that they've hit a healthcare system at all. It just, oh look, there's an open port. We can do something with that. Sometimes it is targeted. Even with the targeted ones, they'll usually start with a bunch of scripts. So what can you do? Basically, don't assume hackers don't know about any vulnerabilities that are out there, because they don't actually have to know. They just download an update to their hacker tools platform. It already knows about the vulnerabilities. So as soon as vulnerabilities are announced, those things are out there and they are being exploited. So key thing is patch your systems, patch them regularly. There are places where you can look up what all the CVEs are for the latest exploited vulnerabilities. Have somebody on your team whose job it is to actually know if you're vulnerable to something. In your own applications, you can actually use static code analysis. So here are a couple of examples: Snike, SonarQube, HP Fortify. There are others out there that you can have as part of your build process, and it will look for vulnerable dependencies that your code relies on. It's not, they don't necessarily look through all your code to find vulnerabilities in your code, although some of them do. But even just knowing that you're relying on an NPM package that has some exposed vulnerability is a useful thing to know and address. You also probably want to think about putting a web application firewall in front of all your applications if you haven't already done that. So Cloudflare, Akamai are good examples. The other cloud services all have one. Amazon has CloudFront. But that allows you to, that will catch a lot of things before they actually are able to reach your servers. Won't catch everything, but a lot of these bot scans, they're able to look for signatures and figure that out. And also just close all the unused ports. There's a search engine out there called Shodan, where you can just do a search for open webcams that people have just left open on the internet. You can go log into it and you can see what's going on right now in somebody's house or wherever. So yeah, close ports you don't need. So let's talk about SQL injection. This has been going on for 40 years probably. Basic idea is that you're able to pass a database command through a URL or through some other sort of web means. And that's able to actually execute on the database. And rather than just getting data by an ID, you're actually able to do things with that data or get back a lot of data. It actually also works for NoSQL databases, for Mongo and other things. So here's a quick example of SQL injection. A lot of you have probably seen this. The main point here is if you name your son with an unusual name that has some SQL statements in it, you can actually do bad things. Look up xkcd.com. There's a lot of good stuff up there. And these slides will be available online. You can go find that later. So Crosssite Scripting is another example of this. You can basically put JavaScript onto a page that then the doctor is basically able to access. So once the JavaScript is there, when a doctor or a user or any sort of person who's accessing that website actually then loads this bad JavaScript on their page, they think it's a fine page because it has your branding and whatever it is on it. But then there's this other thing that maybe installs a keylogger or it reads their sessions. So how do you block that? Really just always sanitize your inputs. It's actually the same thing you do with SQL injection and you do with cross-site scripting. Make sure you know what's coming in and that it's the format you expect and that there isn't weird stuff in there. Really don't trust the data that people send you. Check it first. It's also for database access, it's good to use an abstraction layer like an ORM. Don't ever hand code SQL statements because this kind of thing is guaranteed to happen to you at some point. And actually the OWASP group has a great set of recommendations for how to, for good coding practices around these kinds of attacks. These two are in the top 10 consistently year over year. So in the FHIR world, one of the places that this shows up is actually in the narrative object, which is an HTML object. The spec says don't put active elements in there, but what exactly does that mean? If you were able to get something in that was JavaScript that ran when the payload came up, it would basically run in the doctor's context because they're the ones actually looking at this. So that means that JavaScript now has access to whatever the doctor has. Another interesting use case is if you actually reference an image, there is a way to embed executable code into image files. I don't know how to do it, but Dan does. He can show you after. But if you allow images to be executable on your server, which is basically you just don't configure permissions properly, that code in the image can actually execute on your server and do bad things. So compromise the operating system.
Also, you can put a reference to the external image in the narrative and track when the narrative is viewed. And if the implementation is careless, interesting headers like authorization will escape.
Ah, yes. Right. So I talk about some of that later, but not that particular case. That's pretty interesting as well. There is a lot of detail, actually, if you look at the narrative resource. It talks about a bunch of things that you need to be aware of sort of as active elements. But there are actually a lot of active elements. Usually they start with on. On click is the one everyone knows about, but there's on hover, there's on error, there's on scroll, things that can trigger this. It's actually pretty hard to write regular expressions that can just find every possible variation of that and scrub it out. So even though the spec says you should do that, if you're building a server or some kind of application that cares about this, it's not trivial to actually get that to work properly. You definitely want to make sure images are not executable. That's usually a server configuration, but it's a thing to be aware of. And we actually recommend that rather than even allowing clients to submit a narrative to you, you basically have the server auto-generate them using some template and applying that to whatever the data is. And that way you can at least guarantee that that narrative is controlled. You know exactly what it's going to be. You don't just let random people or even known people with security credentials actually write stuff into that field. So compromised credentials is always a problem. So hackers can gain credentials in a lot of ways. Phishing is an extremely common method, still works. And actually, increasingly, it's easy to brute force passwords. I'll talk about that more in a moment. But once you have a password for somebody or login information, you can log in as that person. You can do anything that they can do. So how do you protect credentials? Well, use two-factor authentication everywhere. That's now becoming fairly common practice. It's actually not a ton of overhead anymore. Use a password manager within your organization so people don't actually have to use the same password in all the different websites or write it on sticky notes or things like that. Make sure your users are all using their own separate accounts. They're not logging in through one account so you can actually track it. But key is don't give people more access than they need, because actually if their account is compromised and then, you know, so say a system admin's account is compromised, they have access to do anything, right? And that means that the hacker now has access to do anything. If they have a very limited scope for that user account, then the hacker can only do that thing. And then if they have a different account to do something else, the hacker has to compromise that one as well. So phishing right now really is often the easiest way to get health data. Like you could hack into the system, but it's so much easier if you can just phish all the employees. Somebody's going to click on that link, and now you can get in. So keep that in mind. And you know, password hygiene is sort of outside the scope of FHIR, but it's still a key vector into your system for a hacker. So quick word on passwords, also from XKCD. The key thing right now is that they need to be long. So all the other stuff you learned about, symbols and capitals and lowercase and extra complexity like that, really doesn't matter. Brute force algorithms are now fast enough that it won't take very long for somebody to be able to brute force an 8-character password. A 32-character password, great. It'll take them, you know, a couple of years with current technology. So, you know, this I think illustrates that pretty clearly, that you can create memorable passwords that are super secure and that don't have a lot of weird stuff in them. Another fun one is man-in-the-middle attacks. A hacker basically sets up a fake server somewhere or somehow intercepts the traffic. This is actually pretty hard to do on a global scale. You have to do DNS attacks, and that gets pretty tricky. But if a hacker is actually already inside of a network somehow, it's actually very easy to do. You can just sniff traffic using a program like Wireshark. You can create sort of special DNS routes inside the network, and then it's actually pretty easy to watch traffic flow through. And once you've intercepted communication, you can see whatever users are seeing. So if they're looking at sensitive data, you can see that data. You can also impersonate them and then do things sort of on their behalf as them. So encrypt everything. This is also fairly standard. Everyone should already be doing this. But yeah, don't use TLS 1.0, 1.1. They have been cracked and are no longer secure. SHA-1, same thing. Use the strongest technologies available right now. And make sure you're always using trusted certificates so that a user will know if there's a man in the middle and that they're not talking to the server they think they're talking to. Another thing involving phishing actually is that people will often register domain names that look very much like your domain name but might be .co instead of .com or might have some spelling error. So if you have control over your domains, go and buy all the variants that you can, and then that will cut down on the ways in which people can do that. So in the FHIR world, again, there are some fun things that you can do with OAuth tokens, actually. So if you have a valid JWT token, and you're able to acquire a signature key for that, which might be that that signature key is exposed in the client. It might be that you've actually brute forced the token and are able to extract the signature key from it. Once you have that, you can alter the token any way you want, re-sign it, submit it, and it will look valid. So you can use that to escalate what privileges you have. So, you know, change what scopes the token has. If there's a patient ID in there, you can remove the patient ID, and now you can see all patients. So how do you protect against that? Well, easiest thing is actually go ask the OAuth server every time you get a token, is this token valid? And the OAuth server should be keeping track of which tokens it's actually created. You can also do, you can put random state parameters in there, which the server is keeping track of as well, so it knows, okay, I've issued a token with this state. Those states periodically expire. There are a bunch of techniques that are described pretty clearly in the Smart on FHIR best practices guides about how to handle tokens effectively. But the key thing is don't just trust a token that comes in and say, okay, it must be valid. Go double check that first. There's also an interesting distinction actually between the JWS and JWE technology. JWS is not a secure way to do secure JWT tokens. JWE is. Ask Dan for more information after this talk on that. I'll move on, but that's out there as well. So an interesting exploit that you can do with FHIR as well is actually query for data you're not really supposed to have. And the server doesn't actually have to give you this data. It really just has to imply somehow that that data is there. So quick quiz, what should happen when a patient queries the patient's search endpoint? Well, an obvious approach is just say they're not allowed to do that. But maybe your server hasn't locked it down that way. Perhaps doing a patient's query is a legitimate thing to do. What happens if I get back unauthorized for a whole bunch of records that I don't have access to, but that match my query? Well, then I can figure out, well, what if I change my query? Do I still get as many records? Do I get more records? And you can sort of work your way down the tree, kind of asking 20 questions, that'll game to figure out, does a record exist in this database? So what should happen in this particular case, and there are other examples of this too, is return one record if your patient record matches what you queried, 0 records if it doesn't, and try to exclude any evidence at all that there might be other records. That will sort of limit the ability for somebody to try to figure this out. So really, missing data and unauthorized data should be completely indistinguishable when they come out of your FHIR server. So don't report to somebody why they don't have access to something. There's also an interesting case I was talking about earlier about timing attacks. You can figure out, depending on how long something takes to come back, whether there might be an answer there or not. The resolution of that is, I'm not going to address here, but it's a thing to consider. You also want to make sure you're not exposing stack traces or other kind of log messages that the user doesn't really need to know, but that might expose some things about your system. And there's more under the access denied section of the security thing within FHIR about sort of what those responses should look like. And if you expose this, what will people be able to surmise as a result of that? So some other fun things in FHIR, you can do recursive denial of service. So sort of along with the timing attacks kind of thing, you can craft some queries that go way down into the weeds of your server and return a lot of nested objects and possibly recursively nested things, and just takes a really long time to come back. And that can actually slow down your server for other users. And a different one that's kind of related is you actually can push bad URLs when you're uploading resources. You can reference a terminology server that doesn't exist, or one that's actually compromised that you control and you have bad code on there. And then whenever that response comes back, or structure definitions, URLs of some kind that are within FHIR, if that goes out to your server, and an exploit could be pulled back into your server and executed and then be able to compromise it. So don't trust things that come from external URLs. Same way you wouldn't trust inputs. Make sure that the server response is actually what you would expect it to be. There's nothing weird in there. You might want to whitelist which servers are even valid to go and ask for terminologies from. You probably want to put some kind of recursion control in your responses when you're serving up FHIR resources, so that you can't go more than like 6 levels deep, or it'll cut it off at some point, so that you don't just crash the servers. And just generally use scalable infrastructure. Cloud infrastructure is great, auto-scaling, serverless. So once a hacker is in your system, what else can they do? So if you're trying to get to sensitive data that you can't find in your particular application, well, see if you can gain access to the operating system. Maybe you can actually get to run a shell basically in your browser that's now running on that server. Once you do that, you can see if you can gain root access to that. Once you have root access, you can now start probing around your network and see what else might be available in that network. You can jump over to that box. You can then do the same exploits. And eventually, you can actually maybe find where the database is of sensitive data and start pulling it down. And with this kind of thing, you actually can have a shell into somebody's network, and maybe they don't even know about it. You can start pulling data out. So minimize access. Always microsegment your microsegment your network. Also make sure that users only have access to what they need, and that you have service accounts that are separate from user accounts, so that the application is running in an account that can't sudo to root, because that's an easy way to get root access once you have an application. You want to make sure your keys are being rotated frequently. You might want to think about monitoring network traffic. So there are appliances that you can get that basically sit on your network and watch network traffic and look for suspicious activity. So a good hacker who's done that and maybe compromised your system is also going to want to cover their tracks. So they're actually going to go see if they can find your logs, and they can maybe remove the things that they produced as log messages from that, and then maybe they can go undetected for months and you'll never even know that they're in there with good log hygiene. So how do you protect against that? Well, one, log everything. Make sure you're even capturing what people are doing. But make sure, and more importantly, that those logs are actually isolated from all your other data. Don't store them with your FHIR resources. And so this applies not just to application logs and system-generated logs, but actually also audit events, provenance, things like that about the FHIR server and its operations. That you want to make sure people can't change it. So you also want to set up your logs that they're append only, that there are no user accounts that have access to deleting log messages. It's also a good idea generally in cloud infrastructure to use a cloud-based logging platform. The cloud providers all give you ones within the platform. You can also go out and do like Elk Stack or Splunk or things like that. They're great. Then you don't have to manage these things themselves. They give you analytics, a whole bunch of other things. So here's a quick example of a microsegmented network. This is sort of microsegmentation. You probably want segmentation inside of these networks as well. But suppose, for example, you're running a public website. Maybe it's WordPress or Drupal or something that has a big footprint and has a lot of vulnerability potentially, but has no sensitive data in it. You then maybe have something that does have sensitive data, like a patient portal. Perhaps that needs some services that are actually inside of your hospital's internal network. So you establish some VPNs, you're able to pull the data back and forth. Well, so because it's segmented in this way, what happens if there is a breach? For example, ransomware in the internal network, or your patient application gets segmented somehow. Well, you can pretty easily close off some ports and keep the systems isolated from each other so that the breach can't spread. So at Asymmetrik, we built a FHIR server using Nodejs. One of the key things about it is actually that it has security sort of baked in from the ground up. That was one of the goals of it. It won the ONC Security Challenge, which is why I bring it up here. So a lot of the way it does that is we don't really know, if you're using our Nodejs framework, you'll be implementing some back-end thing that connects from FHIR resources to your database somewhere and actually is able to do all the transformations. We don't really know that, like, what you're doing at that point. Maybe you're protecting the data properly, maybe you're not. So we put into the framework a lot of these kinds of protections, a lot of validation, making sure that you can't pass bad things in. We have a mechanism to separate out the log storage. It has a whole OAuth 2 thing with Smart. It has a pretty robust scopes definition, so that if I have patient ID 1 in my scope and the implementer of the get patient endpoint didn't bother to even check for what that patient ID is and just gives all the records back, we actually still strip off anything that doesn't have that patient ID. So you still have to understand security to use it, but it deals with a lot of these things. There are also a lot of great work happening in the cloud provider space. So if you're using, for example, Microsoft's FHIR server directly, they're dealing with a lot of the security at the storage layer. There's still things you need to be concerned about in microsegmentation and user accounts and passwords and all the things here, but there may be other things that you don't have to worry about. They're dealing with logging. So look for those kinds of things. You don't have to build all of this yourself. You can use things that are already out there. So as a developer, what's your responsibility? Well, so in the hacking world, there are a couple of key concepts. One is defense in depth, which really means that you need defense at every level of your stack. It's not good enough to just put it at the top. It's not good enough to just have it in the application. You sort of need it everywhere, because a breach could end up somewhere in the middle of your stack, and then you have no protection, and then what? So the other concept is limiting the blast radius. If there is a breach, how do you limit it so that it can't escape and start impacting other things? So security is everyone's problem. If you're a developer, I assume a lot of people in this room are, you can't just throw it off to the security people at your company to be like, okay, look, here's my app, go secure it. They don't like that very much because they don't know what your app is doing, right? You have to actually understand these things. You have to make sure you're not doing SQL injection. It's a pretty common problem. They don't really teach much about it in schools. People basically learn it on the job. Everyone has to learn it. That's sort of the nature of this thing. But the concept that's been sort of emerging in the development community is devs. So DevOps was, sort of taking your code and automating it with CI/CD, being able to sort of automate the process of getting it deployed. DevSecOps is that plus an additional security layer sort of added on top of it. And really the idea is that all the developers are responsible ultimately for all pieces of that pipeline. So there really is no silver bullet for security. There are a lot of things you can do. There are a lot of things you should do. That also can kind of seem overwhelming, but primarily just make sure your systems are patched. You don't have these sort of obvious vulnerabilities. The FHIR spec is actually pretty good at this point about defining what a lot of the things are that you should be doing. Make sure you actually follow all of that and you implement it properly. And that applies on the client side as well. Don't trust that the server you're talking to hasn't been compromised. So you can also do fun things like organize penetration testing events at your company. Get some hackers to try to figure out if they can get their way in, either employ some or hire, contract with some people who can sort of help validate that your architecture is actually secure or point out where it's not. And you can also offer bug bounties. People tend to like that. It means you're putting up money up front, but then you're sort of going out to the community and saying, tell us where we can do better. And just expect that the unexpected will probably happen with your system. So we do have a hacking challenge that we've arranged. So we have the table in the back of the atrium right near the front door. I guess maybe that's the front of the atrium. I don't know. But so we'll be there during breaks. And Dan's going to try to do an organized session at 2:40 tomorrow. Which is one of the sort of coffee breaks between two key speakers. You download a virtual machine. It has an unsecure version of FHIR inside the VM. It also has a whole bunch of hacking tools. He has a whole tutorial you can step through and trying all these different attacks yourself and seeing what happens and seeing how they work. We'll be available for questions. We'll also just be back there any other time if you want to come talk to us, and the exercises on the FHIR DevDays site as well. Here are a couple of security resources you can take away. You can get to these slides afterward. Don't bother writing them all down. But FHIR has a good security page. Smart on FHIR has best practices. And then you should also kind of go outside the FHIR community and look at what OWASP is doing and look through the Verizon data breach. It's a good read. It's actually pretty funny. And it has a lot of great statistics on what's going on right now or last year in the security industry. So, and Asymmetrik also has some stuff that you can go download. We have some songs about FHIR. Thanks. So, I think we have time for a few questions. Right behind you.
You mentioned that we shouldn't take, as part of the narrative field, we shouldn't accept input from users, but only generate it. And I guess this applies for external systems, so we shouldn't accept narrative fields from external systems that we don't trust. But then why don't we just remove it from the standard? Because then we would never render each other's HTML formatted narrative fields. And this is not just for you, but to the entire community.
Well, so I think there are valid use cases where you would want to do things. The key thing there is trust them or strip out anything that might be bad. The spec is actually pretty clear on what is valid and what isn't. So I think that there are use cases where it would make sense to sort of have them authored and have them sort of sent between systems. If you're doing that, you want to make sure you're taking proper precautions. The alternative to taking those precautions is just say, we're just going to generate the narrative and we know what it's going to be because it will always be from this template. But that's certainly not the only way to do it. And Graham might have an opinion about that as well.
Yeah, I just want to point out that any valid narrative is safe.
Right.
Any valid narrative is safe because it's not allowed to include any active content. And the validator is pretty forward about checking that for exactly this reason. So you can defend your system for narrative by using the FHIR validator.
Right. So if you're using the FHIR validator, it already does this. Part of our comment here was that not all servers are using the same validator in the same way, or they're re-implementing it in various ways. And you want to make sure that your implementation is actually correct. There are a lot of weird edge cases, and we can show some examples of poorly formatted HTML that's still technically valid, but is, you know, it would be hard to catch these kind of active elements if you were very insistent on putting them in there.
So is this FHIR validator using the OWASP sanitizers, for example?
Graham? I'll have Graham answer that question.
So in fact, no, because none of the OWASP static issues can arise in valid conformant XHTML. And I'll give a bounty of something, I'll have to figure out what it is, to anybody who can slip something by the validator. Lots of the things that OWASP test are actually testing functional servers, not static content. And then that's a totally different ballgame, which we have nothing to do with. That's where most of the action is. There's a few tricky things you can try and slip by in XML. I'm pretty sure I catch them all. Yep, challenge.
Challenge accepted.
Show me wrong.
So we have a hacking exercise out there. Come try to see if Graham is correct about that. Other questions? Looks like not. Oh, one from the front.
One of the things that keep me up at night is actually authorization access to certain resources on FHIR Server, and combined with the very broad dynamic query language that you have in FHIR, how do you make sure that all the resources, you know, usually users are limited to certain patients, or a patient is only limited to its data from itself. However, some of the resources don't actually link back to you know, the same patient, or it could be a cross FHIR environment where multiple patient authorities are assigning IDs to the same patient. That's a very difficult question. And are there any, you know, remarks regarding that, or any implementation guidelines that we can follow?
It is a very difficult question. I would say it really sort of comes down to two things. There is a technology solution to that, where you just have to be very careful about how you're implementing access. If you're in the situation of implementing a FHIR server that has to deal with that, making sure that you're not accidentally exposing things that shouldn't be. The second piece of that, though, is it's actually a human problem of figuring out even what those rules should be. And if you haven't very carefully defined who should have access to what, it's really hard to build a technology that actually enforces those rules. It's kind of a half answer, but anything else? All right, thank you. Come visit us after.